Colorado, about 150 million years ago. The overall climate was arid, resembling a savanna. However, the absence of grasses and flowers meant that the plant life was quite distinct. The dominant vegetation consisted of conifers, alongside ginkgos, cycads, tree ferns, and horsetail rushes. A significant portion of the fossilized plant life was riparian, thriving along the river floodplains. Brachiosaurus, a herbivorous sauropod. Like all sauropod dinosaurs, Brachiosaurus was a four-legged creature characterized by a small skull, an elongated neck, substantial trunk with a high ellipsoid cross-section, a long, powerful tail, and slender, column-like limbs. Large air sacs that were linked to the lung system were found in the neck and trunk, permeating the vertebrae and ribs through bone resorption, which significantly decreased the overall density of the body. Although the neck is not preserved in the holotype specimen, it was exceptionally long even by sauropod standards, as seen in the closely related Giraffatiticum, which had 13 elongated cervical, neck, vertebrae. The neck maintained a slight S-curve, featuring bent lower and upper sections with a straight middle section. Brachiosaurus likely shared with Giraffatiticum the very elongated neck ribs that extended along the underside of the neck, overlapping several preceding vertebrae. These bony rods were connected to neck muscles at their ends, enabling these muscles to control the distal parts of the neck while being situated closer to the trunk, thereby reducing the weight of the distal neck sections. It has been proposed that Brachiosaurus might rear up on its hind legs to feed, utilizing its tail for additional ground support. A comprehensive analysis based on physical modeling conducted by a paleontologist revealed that although many sauropods had the ability to rear, the unique body shape and limb length ratio of Brachiosaurids rendered them particularly ill-equipped for this behavior. The forward placement of its center of mass would have created stability issues and necessitated excessively large forces in the hips to achieve an upright position. Furthermore, Brachiosaurus would have only gained an additional 33% in feeding height, in contrast to other sauropods, for which rearing could have tripled their feeding height. A bipedal stance might have been employed by Brachiosaurus in rare circumstances, such as during male dominance contests. The downward mobility of Brachiosaurus's neck would have enabled it to access open water at foot level while standing upright. In contrast, modern giraffes spread their forelimbs to lower their mouths into a more horizontal position, facilitating easier water consumption. It seems improbable that Brachiosaurus could have achieved a stable posture in this manner, compelling the creature to plunge its snout almost vertically into the water's surface. This action would have submerged its fleshy nostrils if they were situated at the tip of the snout, as previously hypothesized. Consequently, in 2016, researchers dismissed this interpretation and proposed that the nostrils were actually positioned at the top of the head, above the bony nostrils, as traditionally believed. The nostrils may have evolved to their retracted position to enable the animal to breathe while drinking. Brachiosaurus fossils have been found in North America, specifically in Colorado, Utah, and Wyoming. In sauropods such as Brachiosaurus, the air sacs served not only as a respiratory aid, they were linked to a significant portion of the skeleton through air channels. These branches, known as diverticula, penetrated many bones through pneumatic openings, resulting in substantial hollowing. While the exact evolutionary advantage of this occurrence remains uncertain, it undoubtedly reduced the weight of the skeleton. Additionally, they may have helped in dissipating excess heat to support thermoregulation. The term Brachiosaurus translates to arm lizard in Greek, originating from the words brachion meaning arm and sauros meaning lizard. This name was assigned to the dinosaur due to its forelegs being significantly longer than its hind legs, a unique characteristic among sauropods that enabled it to access food high up in trees. Diplodocus, a herbivorous sauropod. Diplodocus possessed teeth that were quite distinct from those of other sauropods. The crowns are elongated and slender, with an elliptical shape in cross-section, culminating in a blunt, triangular tip. The apex exhibits the most significant wear facet. However, in contrast to all other wear patterns seen in sauropods, the wear patterns in diplodocines occur on the cheek side of both the upper and lower teeth. This suggests that the feeding mechanism of Diplodocus and its relatives was fundamentally different from that of other sauropods. The most probable feeding behavior of Diplodocus is unilateral branch stripping, which accounts for the peculiar wear patterns on its teeth. In this method, one row of teeth would be employed to strip leaves from the stem, while the other would serve as a guide and stabilizer. Diplodocus possessed teeth that were quite distinct from those of other sauropods. The crowns are elongated and slender, with an elliptical shape in cross-section, culminating in a blunt, triangular tip. The apex exhibits the most significant wear facet. However, in contrast to all other wear patterns seen in sauropods, the wear patterns in diplodocines occur on the cheek side of both the upper and lower teeth. This suggests that the feeding mechanism of Diplodocus and its relatives was fundamentally different from that of other sauropods. The most probable feeding behavior of Diplodocus is unilateral branch stripping, which accounts for the peculiar wear patterns on its teeth. In this method, one row of teeth would be employed to strip leaves from the stem, while the other would serve as a guide and stabilizer. Diplodocus fossils have been found in North America, specifically in Colorado, Utah, and Wyoming. Although there is no evidence to suggest the nesting behaviors of Diplodocus, other sauropods like the Titanosaurian Saltosaurus have been linked to nesting locations. These Titanosaurian nesting sites imply that they might have laid their eggs in a communal manner across a vast area, utilizing numerous shallow pits, each one covered with plant life. It is possible that Diplodocus followed a similar practice. The documentary Walking with Dinosaurs depicted a mother Diplodocus employing an ovipositor to deposit her eggs, but this was merely conjecture from the documentary's creator. For Diplodocus and other sauropods, the size of their clutches and individual eggs was surprisingly small, especially considering their massive size. This likely served as an adaptation to the threats posed by predators, as larger eggs would necessitate longer incubation periods, thereby increasing their vulnerability. The name Diplodocus translates to double beam due to the unique double-beamed, or two-pronged, chevron bones located beneath its tail vertebrae. This name is derived from the Greek words diplos, which means double, and dokos, which means beam. The diplodocus herd have crossed into the site of the Brachiosaurus herd. Between the herds of Brachiosaurus and diplodocus will arise from competition for resources, as their distinct feeding habits, with Brachiosaurus grazing at greater heights and diplodocus at lower levels, would lead to their closeness and subsequent clashes, even though they generally maintained a potentially neutral relationship. The diplodocus's strong, whip-like tail could serve as a defensive tool against another sizable herbivore, possibly during a food standoff.